Hello and welcome to the VEST webinar series. I'm Megan O'Neill, your moderator for today's webinar session. Today we'll demonstrate how to design manifolds with integrated filter cavities using MDTools. This webinar will last approximately 45 minutes. You'll be able to submit questions or comments at any time during the webinar by posting in the questions section located within your webinar control panel. Questions may be answered as they are posted, or we'll try to address them in the last 5 minutes of the webinar. Note that today's session is being recorded and the audio is muted for all attendees. If you are experiencing any technical issues, please use the chat window to alert our support staff. Now it is my pleasure to introduce our speaker for today's webinar session, Carlo Molon. Carlo has worked in the hydraulics industry for many years and currently manages application sales and training for VEST desktop and cloud products. Carlo?
Thank you, Megan. Thank you all attendees for joining today's webinar. Today we look at a slightly different workflow compared to last MDTools webinar I made. My task today is to show how to design a manifold with an integrated filter cavity. I will start, instead of from scratch, I'll start from a pre-existing manifold where I have put a flange mounted filter. So the diagram is not that complex, but due to the time constraint we have, we cannot do too complex stuff. Basically, I have a small manifold where I have a filter with a bypass valve, the check valve, an unloading valve, a proportional relief valve, and just a directional control valve, NG10. Sometimes people place filters in pressure to prevent damages to expensive components like servo valves, proportional valves. It's very common in all the power units. You find the filters in the return line, but in pressure lines, it's pretty popular as well. Now my challenge is to study a couple of different variations of a design, and instead of using a flange filter, try to fit directly the filter into the manifold. So I have already made a version of the manifold with the flanged filter. I have done it from HydroCAD. Next webinar will show a bit of the interaction that exists between Hydro and MDTools, so we'll try to get deeper in how to optimize the workflow. For now, the design is made. I have all my Hydro components there. I'll start from the assembly part, and we'll do some consideration and then start our project today. So I'll do an automatic assembly for my manifold, for my flange filter. And here is my assembled manifold. In case of cartridge valves, we always have the possibility to rotate coils or cartridge in case we need. So if we look at how this design is made, basically my intent was to have a pressure and tank on one side, A and B on the opposite. All the manifold is assembled through the back face, so with the through bolt holes from the front face. And as you can see, there is a large filter on top. So this is a very standardized application, but of course we can see that the dimension, the overall dimension is quite big. We have almost 200 millimeters. So my intent here is to, instead of flanging directly a filter, to take just a cartridge of the filter with the filter element and build a cavity inside the manifold. This year I had a couple of similar situations practically in my work where I had the need to put a filter cavity inside a manifold. Let's study a bit how these are made. So basically, I just took some screenshot from a catalog. In this case, it's an MP filter. This is the type of filter I have in my application. So it's just a FHP 050, and we have the body, cast iron body with in and out. Basically, the cast iron, we can see in this exploded view, is like a manifold. It's not made like a manifold in terms of drilling, but it has channels inside that do connect the external and internal of the chamber of the filter. So basically, in the filter, we have the inlet that is bottom here. It goes outside, and the oil is filtered and enters into the chamber of the filter and goes into the internal, and this is the outlet. So the dirty oil gets in, enter from the outside of the cartridge, and flows into the entrance and goes there. Basically, what we see here, the external is like a manifold, like I said a few seconds earlier. It is possible in some application really to don't assemble completely, but use only the cartridge element. So I got a catalog from MP-Filtry that shows the application. So my filter will be this HPB 050, and it has some description, but what I am interested into is the cavity. So this is the cavity for this filter. Let's study a bit, and then we can see the limitation that we have with MDTools and how to overcome them during our design. Let me get back to my whiteboard, and let me paste my cartridge. So this is the cartridge. The cartridge is made of two elements, the filter element and the bottle, the external. So the filter element will enter here. The oil will come inside from the radial diameters, and then it will enter inside. What is particular of this application is that practically the geometry in the manifold must have this protrusion inside, because it must keep separation between the inlet and the outlet of the filter. For those that are already aware of MDTools behavior, we know that it is not possible in the library to model this kind of geometry, this protrusion that we have here. So I will show you how to model part of this cavity in with MDTools Library Manager, and later how to add this geometry into Inventor. So today I'm going to use MDTools for Inventor, but this exercise can be made absolutely 100% with MDTools for SolidWorks. So let's go for the Library Manager first. So I have my cavity made, this HPB 050. So this kind of cavity has to be modeled like an interface pattern. An interface pattern can have just drills or a cartridge. In this case, the main cavity for me is a cartridge. So as you can see, the primary cavity is a cartridge. It is made with all the different diameters, and it's a cartridge because this is the only way we can have in MDTools Library Manager to model it properly. And I have just one port. It could have been modeled like a port because it's a one-way entity, but port cannot be added to interface pattern. So the only way to create in MDTools is to use the interface pattern with a cartridge at one way. Additionally, so with this dialog, I model really just the external of the filter cavity. In edit footprint data, I have added a couple of inlet. So in this situation, in this type of components, there is really not a unique. So in this cross section, you can see two drills. So 1 and 2. We could really have like an annular connection. We can have 2 drills on one side, 3 drills. The fact that you add 2, 3, 4 drills is just to, in case you have high flow rate, and you should just dimension the number of drills that you need in terms of the flow rate that you need to manage with your component. Of course, it's always better to give symmetry. This will not be our case for today, but if you have inlet on one side, it is better to to try to symmetrize the inlet flow so that the cartridge of the filter will work better. But in terms of design, really, sometimes it's more the geometry that is driving us and constraining to where we enter. But basically, what we need in our application is at least one inlet, and the outlet is in the center. So in my case, I modeled my cavity with the two inlet on the opposite side, and case to case, we can decide if we need one of them, two, or we can even move them in our block. So now let's get back to our design, and let me open just the block, and I'll start modifying my design with the new cartridge. So let me save this block, save as, and that will be webinar flanged filter. I will save my assembly. So sorry for not doing that. Save, because later we'll do a change. Let me do filter assembly. And if you have any question, feel free to post. So now we are here in the flange, in the block. I don't need anymore this component 5, which is my filter. So I'll start removing cavities that I don't need. Delete cavity. So today, really what I like to show is also the ability to quickly manipulate our manifold design in case we need to have a large modification to our block. Sometimes we just move cavities all around with material, but in this case, really I need probably to change phase to components and try to find some good solution to my design. Let me also delete some plugs. So in this case, let me delete this inclined drill. I also don't need now. First, I'll start placing the filter cavity. So I go into my cavity library and take my MP filters folder, and I'll take my HPB 050. So let me get back to the diagram. In my diagram, when we use Hydro to MDTools, after you run the export to MDTools command, basically after you created the networks, we will see in the next webinar in a couple of weeks, all the lines will have a net name, so it's easy to retrieve the net name. So as you can see, the filter here is working between a net called P, which is the inlet, and a net called P1, which is the outlet of the filter. So in my case, I will, after I select HPB 050, I will use the P1 as the outlet and P as the inlet. And let me use both the drills. We'll see later if we need them. And let me call it cartridge filter. When we insert a cavity in MDTools, we always need a component ID. It could be item 5, item 7, depending on our diagram. Let me just give a name and position somewhere here. I like to position near in the center and click OK. And at least we can see. Okay, it looks not really a good position for our valves, but let's start. Let me delete some plugs. And of course, we need to help ourselves with the colors. This one was a check valve, is a valve number 4. Now that we don't have anymore the filter on this face, we have all this face free for components. And although my intent is to limit the total width of this block, I can accept, as a designer, I can accept to have my cartridge valve here. The check valve normally does not have a long impact in height. So I just change phase and do a connection with the same cavity. Yeah. By doing this, of course, I remove a cavity that was not in a good position. I also get all the red part, so all the inlet on one side, which is good because now the connection will be very, very easy. This valve cannot be in a good position here. This is a solenoid valve, so it's the normally open valve as a bypass. It was a valve number 1 here. So let's see, a good position could be maybe change phase and reposition in the opposite side. Let's see if that works. Otherwise, we'll change later. For the time being, the test point, I can move somewhere in that position, and later we'll try to fit. Now, I just get rid of this plug as well. And I want to connect the red connection just up here, and maybe slightly more. The position for this drill is not mandatory. It can be any direction. So by looking at the geometry, I think a slight rotation to the filter cavity can be done. Although it's a cylindrical geometry, but in this case, I have 2 drills connected together, so I can rotate the entire footprint by maybe 20 degrees or 330 degrees in order to have the drill in a better position, so to have a better connection here. And I can use stretch command to insert here. We must always remember that we will need to have the protrusion inside, but we will add later in our geometry around the end of the design. A port is not in a good position. We can see it's entering inside the filter cavity. So let me gain some space. So let me move the B port slightly up. And also I want to move my cavity to the left. To have a better connection, I need an inclined drill. So I can just use a stretch, this drill with inclination up to here. And maybe I can reduce a bit the inclination. And now this position is better. In case you see graphic artifacts, click color. This will recreate all the colors for the cavities. Now the orange is the easiest connection. We can just use a stretch, this drill, and we go directly here. We could also incline slightly a bit, maybe 5 degrees. When you use stretch, remember sometimes it's not handy because you can change the alpha and beta inclination. So if you decide to fix an inclination, like in my case 5 degrees and 270, it's better you lock both so that when you stretch the tip, you just stretch in the direction that you want. So that's an easy way to change the depth. That's okay. I think I'll swap this cavity, swap 1 and 2. Swap is a command I don't use frequently, but when I need it, it's very interesting because if you see that the position of the cavity is not the right that you expect. So in this case, my idea is to create the tank line using this the light blue and use the orange in the front face. So this is easier for me in this case to envision how the block has to be made. So I connect the orange here, and I can add a construction port here to connect in the center. No, let me do again. I add a construction port to port number 2, 1x4, somewhere here. And in this case, I'm going to maybe move multiple 1 and 2 and move back to this position. So here I have an easy connection. Let me get rid of this plug. Easy connection with the orange, and let me extend the orange also on the other side. So all the other orange lines are connected, and now really I have an easy spot for the connection. Yeah. and let me extend it here. In this case, I can see that I have a drill touching the thread of the plug. Sometimes I prefer to change the depth of my spot face, even if in this case I will have a bit of the plug extending on this side. This will not be a big problem. Also, I have the check valve on this side. Now I can do the connection for the tank export, port number 2. I just need a 1x4 BSP port on this face in the center. And I can stretch my drill here and extend this also. This is not a very complex block, so normally in this case I don't use too many connection check. But when you do the connection check, this command will always give you warning if there are problems, wrong connection, or so I have broken networks. This is a false warning, so it's saying that there is an intersection between the inlet and the outlet, but this is how MDTools is considering this type of cavity. So this you must ignore. It's basically considered an intersection between the orange and the red because they are inside the same cavity, but it's not a real problem. There will be the cartridge that will separate both connections. Of course, this command will give me that the network tank is open, and it will give me also a warning that the pressure is broken. Now, in my case, I will do something tricky. I'm not expected to enter with the pressure on another position. Yeah, I will use here just to read my pressure. So since I have a test point, and when the oil is inside the filter, the pressure will be the same on both sides of the cavity. I can use this drill, the red drill, to connect with the test point. I don't like the position of this drill. This is a command that is only available in MDTools for Inventor. It's called Edit Footprint. With Edit Footprint command, we can change the position for drills in a footprint. In my case, I'll just change it to let me see if this is correct. Yes, and let me rotate again by maybe 15 degrees. Yes. So I have changed the physical position between the drills. This is perfectly fine for this kind of cavity, and I'll just use my drill for the test point. Of course, I could add additional drills. In this case, instead of removing or adding, I just decided to edit the footprint. Let me repeat, edit footprint. This is, again, another command that you don't always need, but when you need it, it's very handy. It allows you to change, also to add cavities in a footprint or remove cavities for a footprint is already part of delete cavity. But it is possible to change a footprint geometry with this command. So I think that overall looks good. The pressure is entering the filter. The P1 is there. I need to connect the return line. Now, as you can see, we have some inclined drills. When you have inclined drills on a face, on a particular direction, so in this case, they are in the horizontal direction, we're looking at here from this view. This drill is oriented in the opposite way. This is not good from manufacturing perspective. If you have 5-axis machine, perfect, but if you have just 4-axis machine, this will be require a new setup. So it's always better to change and have all the inclination going in the same direction. Plus minus is not usually a problem, but it's better not to have a different direction for drills. So in this case, I will use the 90 degrees, maybe 5 degrees better, so that I can also move my drill slightly to the right. Also, I add a construction port to connect my tank lines. And my position is this. And let me stretch it. So the block looks almost okay. By looking at it, we can see that we have some room for improvement. So we can remove some material from the back face, maybe 5 millimeters. So this ends up being a good decision. The idea to bring the filter inside the block, if we can save volume, then it's great in terms of manufacturability. Of course, this cavity will be expensive because the flanger filter requires just 2 bolts and 2 drills. This requires a special tooling or attention, but in this case, the benefit will be good time volume saving. I can also remove some material on the length here. Let me remove maybe 5 millimeter. Pay attention to wall thickness when you have very large drills, because the pressure, since it's a pressure filter, the pressure will act on a large surface. So it's better you pay attention with large drills. So better to have enough wall thickness. What I can see here is I have the spot face of the plug entering inside the bolt holes. So in this situation, a technique that you could adopt is to really sink the plug. Let me make 25 millimeter. So in this case, although you have 2 cavities interfering, but the seal surface will be this, so there is no issue at all. And let me match properties. So I do the same here. I just copy the spot face. So you will be able to assemble the plug and also assemble the bolts. To reduce the bolt length, it's also interesting to sync more the spot face. And the match properties allows you to copy the same geometry for all. This situation is at risk. We can measure the distance. 1.64 millimeter. Let me move this down 1, 2, 3, 4, and 5 millimeter. So this will end up being 6 millimeter, and this will be good enough. Of course, we can do wall thickness check for 3 millimeter and do a check for our block. In case of these cavities, you may find, like in my situation, wrong wall thickness problem. They are part of the filter cavity, so this is not a problem. When there are clearance lists within the same footprint, usually it's a false warning. So let me go for 4 millimeter and nothing else. 5 millimeter, nothing really serious. So here we have 4.8 millimeter between the bolt and the tank. The tank is usually at very low pressure, so it really is not a problem. Here also we have 4.5 millimeter between the A port and the tank port. The drill are not large. It's a 10 millimeter drill on an NG10, so 4 millimeter is really a good wall thickness value for 10 millimeter. Let me check what else. We can save our block. The engraving look good. Let me add additional engraving to my cavity. That's engraving 1. This is the check valve. And here also. A is outside, click, edit, location, and we can specify a new location for our block. Now let's focus a bit on the assembly. So we save and get back to the assembly. Actually, we could do another automatic assembly because we just removed the filter, but all the rest stayed as it was in the original block. So let's try the automatic assembly. Automatic assembly, and I'll take my webinar flanged filter. Of course, in this case, MDTools will not be able to place the filter cavity. As you can see, it placed the plugs below. Overall, the geometry looks interesting. And now, as you can see here, really the volume taken by our solution is much less than the previous design. Let me assemble the cavity, the filter element. I have it. In this case, I use just inventor commands. So I'll constrain. So looks good. Of course, I forgot to model the extrusion, the protrusion inside of the cavity. So in terms of layout, the block looks good, very compact. Let me get back to the part and let me model the nose that I need for the filter. Let me take the geometry once. So I'll need 8 millimeter distance. Outside it's 23.7 and inside is 19. So I'll usually in this case I'll help myself with just pure modeling. I create a plane through the center of the cavity, so this will be my working plane. I'll create a sketch in my plane. If you prefer, you can switch off the color. To remove MDTools color, you just go to MDTools, View, Remove Color. I project using the sketch editor. I project entities that I need. So I need this. I also need the center. I'll create a symmetry line from the center. I'll create my nose, so I just do a rectangle. Well, this is not symmetry line, it's just pure lines. So this has collinear constraints with the bottom of the filter cavity. It has a distance of 8 millimeter from the top. It has a 19 millimeter inside diameter, and the external is 23.7. I need a chamfer. And this chamfer is, I think 3 millimeter, if I'm not wrong. Let me get back. 3 by 20. Yes, so 3, and the angle is 20. So this is the sketch. So I'll need to do a revolve with the axis. Okay. And now, as you can see, I have the geometry. Let me switch off the wireframe so that we can see properly. We can also hide the plane. And we can switch on colors again, color. And if we want, we can go back to the wireframe view. Get back to the assembly. And we can save our assembly. Now we have some minutes, so we can check how the machining drawing can be made for this kind of manifold. Since this is a special cavity, normally in this case, my expectation is to create a cross view of the cavity in order to put all the dimensions. In my drawing standards, so let me start the drawing. Let me create the views of my block. And let me auto dimension. And let me do all the machining callouts. So I like to have the drawing with machining callouts describing all the cavities. In this block, there are 4 identical bolt holes. So it is possible to group them by using machining callout. For the selected cavity, you touch one cavity, you click on delete duplicate, yes, and just touch a position. So this is positioning correctly. It's funny, suddenly my inventory is put in inches instead of millimeter. I need to check. I did an update recently, so I think it messed up my settings, but it is fine. All the dimensions are in inches. I'll fix later. Looking back at the cavity details, normally in my drawings, when I make a machine drawing, well, of course, I put the flange, and in this case, the NG10. I have created a macro in Inventor to put all the blocks. Of course, now they are in inches. I'm sorry, I'll need to take a metric drawing, otherwise it's metric ISO. Let me change it to A1. And let me do that again. Dimension should be in millimeter. And also the footprints. And all my cavity blocks are correct. So usually I have created cavity blocks describing the most common cavities. In my case, there are SA10-2 cavities and CTOP 3. Then I have a standard table for the BSP ports and plugs. In case of the filter cavity, I think it's worth creating a cross section. So usually I create a custom cavity drawings for all the standard cavities. For this special situation, I normally make a cross section. So I go to place view section. I just draw a line, continue, and make my cross section. So here I can also verify the geometry. So I can annotate and put a dimension. Well, in my case, it's not precisely. If you struggle with precision, it's better to first create a sketch, draw a line. Well, you can draw the line also where you want. project the center and make the line collinear with the position. Now you can use this line as an element for the section view, so it will be precise. We can add symmetry center lines, and so here now we can put the dimensions 19, 23.7. We can add the tolerances using MDTools command, inventor commands in this case. So we can use a deviation. In this case, I don't remember how much it was, but I mean now it's not anymore. Minus 0.05, so it's 0.05. And so you can put the dimension. Feel free to change, well, it will use the inventor styles that you have. So in my case, I didn't specify. Yes, somehow my inventor setting has changed in the last update I made. I'm missing here the machining callout. You can describe the cavity also here. The description for the cavity is coming from the library manager. So when I go into my library manager, I can see that for the main cavity, I have step 12 and HPB 050 MP filtering. This is what I can see in the machining drawing. I could add also a text, C cross section or C cavity drawing if you have a drawing number for that particular cavity. It's important that you represent the cavity in a realistic way for the manufacturer, for those controlling the block. But of course, you need to be able to get to your result and to your machine drawing properly. I don't see any question. I think I am almost done. Let me just quickly finish the drawing, and then if you have questions, feel free to post. I hope you enjoyed the topic. It was a bit of practical. Let me do again the grouping. Machining callout, select cavity. For this cavity, delete duplicate, yes. Touch a new location. So this command is grouping and removing the identical cavities in the same face. For those using Inventor, a technique to keep good alignment between letters, select, right-click, align vertical or align horizontal. So according, if you need to align horizontal or vertical, you just select, and then it will be easy to give a good alignment. Like in this case, you can just position randomly, like here, then select all, align vertical, and move the text all around. That's all. So I turn it over to Megan. Thank you for attending today's webinar.
All right, very nice, and thank you, Carlo. If you have any questions that were not addressed in the webinar that come to you now or in the next couple of days, feel free to email them in to support@vestusa.com. And that's all the time we have today. Again, send us an email if you have any questions. And we'd be grateful if you could complete a short survey at the conclusion of today's webinar. Tomorrow, you'll receive an email containing a link to view a replay of today's session. Feel free to share this link with your colleagues. A link to view video segments from prior webinars will also be provided in that email. As you can see, we also have a webinar series posted on various social media channels. We invite you to follow these channels so you can receive the latest updates on upcoming webinars as well as product releases. Our next webinar takes place in 2 weeks, where Carlo will demonstrate ways to boost manifold design productivity using HydroCAD. Thank you again, Carlo, and thank you to all for attending today's session. Have a safe and pleasant day.